Welcome. Let us take few more problems on tangent and normal. First problem is the range of lambda so that tangent of y is equal to 2/3 x cube minus lambda x square plus 2x plus 9 makes an acute angle with x-axis. Options are lambda square is less than 1, lambda square is greater than 1, lambda square is less than or equal to 4, and lambda square is greater than or equal to 4. So actually the problem is one curve is given. So we have to find in that curve lambda is one unknown quantity. We have to find the range of lambda so that tangent of that curve to any point makes an acute angle with x-axis. So if tangent makes an acute angle with x-axis, then dy dx must be positive. From given equation, dy dx is equal to 2x square minus 2 lambda x plus 2. So actually dy dx, it depends on x and lambda. In order to get range of lambda, first of all we have to make this one having an x square and x. We have to make these terms perfect square with some other constants, because it depends on x. It cannot be, so that we have it is equal to 2 into lambda x square minus lambda x plus 2 for all values of x. So we have to make this along with some constant a perfect square, so that 2 into it is x minus lambda by 2 whole square. I have taken lambda square by 4 extra, so that we have to adjust it, minus lambda square by 2, lambda square by 4 and 1 2 is there, plus 2. It is positive. Now in order that tangent makes an acute angle, so it must be positive, so that we get 2 minus lambda square by 2 is positive. That is lambda square by 2. Lambda square by 2 is less than or equal to 2. That is lambda square is less than or equal to 4. So this is our correct option. So this is correct option. Next. Harry, I'm family. Our next problem is for the circles x square plus y square is equal to 16 and x square plus y square minus 2y is equal to 0. Number of common tangents. Options. Number of common tangents of these two circles. Options. One pair. Only one. Three. No common tangent. This problem can be solved simply by drawing a rough sketch. This is a circle, its center is at the origin 0, 0. And radius is 4 square, that is 4. For that, its center C is at 0, 1 and radius is 1. So, by drawing it, first of all, this is its center is at the point 0, 0 and radius is 4. So that it is of that type, this one. And for that one, its center is at 0, 1, means somewhere there, 0, 1. And radius is 1. So it is of that type. So these are the two tangents. Now we see that one circle is completely within the first circle. So it is not at all possible to draw one common tangent. So no common tangent is possible. Our next problem. Total number of tangents through 3, 5 that can be drawn to 3x square plus 5y square is equal to 35 and other is 25x square plus 9y square is equal to 450. Options are 4, 3, 2, 1. The question is total number of tangents through that point that can be drawn to this and that. Both are ellipse. This is actually equal to x square by 7 plus y square by this is not 7. It is actually x square by 35 by 3. Y square by 7 is equal to 1. This is equal to x square by 9 plus y square by 9, 5. It is 1. So both are ellipses. And you see, this point lies on that. Because 25 into 9 plus 9 into y square is 25. So it is equal to 9 into 50, that is 450. This point satisfies that. So this point lies on that ellipse. So that of that type. This one is that ellipse, and this is, you see, 7 is less than 50, and it is 35 by 3. It is roughly equal to, this is x square by 9. Just 1 minute. This is actually, this is given as 7. Sorry, problem is this. So that it is equal to 5. But the first ellipse is, its A is 5 and B is 7. It is, both are less than that. So it is of that type. So, and 3, 5 is a point on that. Question is, how many tangents are possible to draw from that point on these two ellipses? One, of course, possible for that one. And from this point, one tangent is this, other tangent is that. No other tangent is possible. So clearly, from that point, 3 tangents are possible on this and that. So answer is our 3. Next problem, the tangent of y is equal to fx makes angle pi by 4 at x is equal to 1 and pi by 3 at x is equal to 2 with x-axis. Then the value of 1 to 2 f dash x f double dash x dx is options 1, 2, 3 and 4. Now let us see what is the actual problem. Y is equal to fx is a given curve, and it is given that at the point x is equal to 1, its tangent makes an angle pi by 4 at x is equal to 1, and tangent makes an angle pi by 3 at x is equal to 2. Then value of this options are given. So given that at x is equal to 1, tangent makes an angle pi by 4. So dy dx is equal to tan pi by 4, that is equal to 1 dy dx. And at x is equal to 2, dy dx at x is equal to 1, at x is equal to 2, dy dx is equal to tan pi by 3, that is, it is equal to root 3. Now pi by 3, okay, just 1 minute. at x is equal to 2, it makes an angle 5 at okay. So now we have to integrate that, definite integral. Put f dash x is equal to z. So f double dash x dx is equal to dz. So this become f dash x means z and f double dash x dx is dz. When x is equal to 1, z is equal to, when x is equal to 1, z means f dash x dy dx, that is equal to 1. When x is equal to 2, dy dx is root 3, that is z is equal to root 3. Now it is very easy to integrate that. It is actually z square by 2, 1 to root 3. So that it is equal to half of, this is 3 minus 1. So 2 by 2, 1. So this option is correct. Next one, y is equal to ax cube plus bx square plus cx plus 5 touches x-axis at p minus 2, when p is minus 2, 0. It meets y-axis at q. At q. Where gradient of tangent is 3. Then values of a, b and c. Values of a, b and c. Options are minus half, minus 3 by 4, 3. First option. Second option is half, minus 3 by 4, 3. Third option is 1, minus 3 by 4 and 2. And fourth option is minus 1, minus 3 by 4 and 2. Okay, now let us see once again what is the problem. One curve is given and in that curve a, b and c are unknown quantities. It touches, given that it touches x-axis at the point P. It meets y-axis at Q, where its gradient of tangent is 3. Then we have to find out the values of A, B and C. So as because the curve touches x-axis at the point, this curve passes through that point. So we must have it satisfied. So 0 is equal to minus 8a plus 4b minus 2c plus 5, number 1. Secondly, it touches x-axis at the point, means x-axis is a tangent of that. So at that point, gradient of tangent must be parallel. It is actually x-axis, so dy dx is equal to 0. Now dy dx actually is equal to 3ax square plus 2bx plus c, and at that point, gradient at that point P is equal to 12a minus 4b plus c. So we get its gradient at the point is this. So we must have 12a minus 4b plus c is equal to 0. Once again it is 0 because it is parallel to x-axis. Third of all, it meets y-axis at q. The point q is x0, y is equal to 5, 0, 5, where gradient of tangent is 3. Therefore, dy dx at q is equal to, q means x is 0, this is 0, this is 0, c. So as per condition, dy dx at q is 3. As per condition, gradient of tangent is 3. So c is equal to 3. So we get c is equal to 3. Now putting these values of c over equation 1 and equation 2, we can very easily solve for a and b. And the option actually, a will be equal to minus a half and b will be equal to minus 3 by 4 and c is 3. So first option is correct. Next. Next problem is find the equation of normal. Find the equation of normals of y is equal to x by 1 minus x square at points where tangent makes an angle pi by 4 with x-axis. So first of all, we have to find the point where tangent makes an angle pi by 4 with x-axis, tangent of that. And at that point, we have to find the equation of normal. As tangent makes an angle pi by 4, so dy dx must be equal to 1. From there, derivative of that, 1 into 1 minus x square minus x into minus 2x divided by 1 minus x square whole square, it is equal to 1. This one, dy dx is 1. So that we get 1 plus 2x square minus x square is equal to 1 minus x square whole square is 1 minus 2x square plus x to the power 4. So that 1 cancels. So we get x to the power 4 is equal to 3x square. That is x square into So x is 0 plus root 3 and minus root 3. So now we obtain that when the value of x is 0, this and that, at the point where tangent makes an angle pi by 4 with x-axis. So x coordinate we get. So y will be equal to 0 when root 3, y is equal to root 3 by 1 minus 3, that is root 3 by 2. And when it is equal to minus root 3, this is equal to root 3 by 2. So points are minus root 3 by 2 and root 3 by 2. So at these 3 points, one is 0, 0, other is this and that, other is this and that. At these 3 points, we have to find the equation of normal. As because you see, as tangent makes an angle pi by 4, that is its gradient of tangent is 1. Therefore, gradient of normal is minus 1. So now very easily we can find equation of normal whose gradient is minus 1 at the point 0, 0, at the point this and that, and so on. Very easily we can obtain that. And the results are number 1, x plus y is equal to 0 at that point 0, 0. Number 2 is x plus y is equal to minus root 3 by 2, and x plus y is equal to root 3 by 2. These tangents are possible at the point on the curve where tangent is parallel, tangent makes an angle pi by 4 with x-axis. So next problem. If ax plus y plus a is equal to 0 is a tangent to the curve y square is equal to 4ax, then a is options 1 or 2, second option 1, third option 2 or 3, third option only 2, fourth option. Given that this is a tangent to that, therefore we have to find from this condition that this is a tangent to that, then we have to find the value of a. There are so many methods, but easiest one I am telling you. Suppose this is this curve is a parabola. If this is a tangent to that, then it will meet the curve only at one point, only at one point. So from this condition, very easily you can do that. Solving this and that, y square is equal to 4 into ax. Ax is equal to minus y minus a. That is y square plus 4y plus 4a is equal to 0. This is a quadratic in y. It must have two values of y. Now, as because it meets the curve only at single point, so two values of y must be same. That is, discriminant of the curve, discriminant of the quadratic equation must vanish. That is, b square minus is equal to 4ac. That is, b square means 16 minus 4, a is 1, c is 4a is equal to 0. That is 16a is equal to 16. So hence a is equal to 1. So only 1. So this is our correct option. Our next problem. AB is a chord of y square is equal to 4x minus 4 parallel to y-axis and passing through 2, 1. Tangents of the parabola are drawn at A and B. Then angle between the tangents. Options: 60 degree, 30 degree, 75 degree, and 90 degree. This is the parabola. It has a chord parallel to y-axis and it is AB. So AB is a chord of that parallel to y-axis. Like that. Its center is at 1. This is a chord AB parallel to y-axis. This passes through the point 2, 1. Say 2, 1 is that point, say. So equation of chord AB, this is equal to, as because it is parallel to y-axis, it is equal to x is equal to something, x is equal to 2. So its x coordinates, it is 2. So A and B can be obtained, coordinate of A and B can be obtained by solving this and that. That is, y square is equal to 4x means 8 minus 4 is equal to 4. So y is equal to plus 2 minus 2. So A point is 2, 2 and B point is 2 minus 2. Now two tangents are drawn there. The angle between the tangents, we have to find that. Now the gradient of tangent at the point A can be obtained from there. It is given that y square is equal to 4x minus 4. Therefore 2y dy dx is equal to 4. Therefore dy dx is equal to 2 by y. So dy dx at the point at A, dy dx is equal to, at the point A is your 2, 2, so 1. And at B, dy dx is equal to minus 1. 2 by minus 2. So product of the gradients is -1. 1 into -1. So product of the gradient of the tangents is -1. So they are at right angle. So option is 90 degree. Okay. Today is up to this. I request you to like the video, to share the video, and subscribe my video channel. Thank you.